whatever the changes made by the users here, so it directly is going to affect the data in the DBMS or in the database. The first record of a database in this model, that is called a root node. So as we have seen in the previous two models, and here we are going to make use of links or connectivity. We are connecting two different records. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion of the topic database concepts. And in this session, let us discuss about database architecture and also database models. Now let us see what is this architecture. Now, what is architecture? The DBMS, Database Management Architecture, it can be seen as a single tier or multi-tier. Actually, this architecture is the nothing but from the how they are going to develop the software or DBMS. Based on that, we have different layers of or different tier of architectures or different types of architecture. Accordingly, this is architecture is logically divided into three types. So this is we are going to connect or it is based on the work. How do we work with the database and how the users will make use of the database. Based on this, we have different types of architecture. Accordingly, so this is logically divided. So into following types, this one is logical one-tier architecture and logical two-tier, or it is also called as client-server architecture. Next one is logical three-tier, also client-server architecture. There are three methods, the three architecture where the user and how we'll make use of this database or DBMS. Now let us see these definitions. First one is logical one-tier architecture. So in one-tier architecture, DBMS is only entity where the user directly sits on DBMS and user set. Now we can observe this diagram here, this schematic diagram here. If you observe this one tier, this is what you can see the file server. This is the one database or DBMS, and all systems or clients they are the users. They are called as the users. So in one tier architecture, the meaning is the user directly sits on the DBMS and user it. The meaning is the systems or the computers or the users. In this example, there are three users. They will work with directly with this DBMS. So that is the meaning of it sits on the DBMS and user set. So any changes done here will directly be on the DBMS itself. So whatever the changes made by the users here, so it directly is going to affect the data in the DBMS or in the database. So obviously the users will directly work with the database. And it does not provide handy tools for end users. Here in this example or in this architecture, there is no separate tool for users. Users directly work with the database. And preferably database designers and programmers use this single tier architecture because this software development or system analysts or designers, see, they are the one they are involving in software development or in DBMS designing. So those are the people, they can directly work with this database. So generally in one tier architecture, only the software people or database designers or programmers, they will work with this database directly. Any changes, so they will be having the knowledge of the database and other details. So this is one tier architecture. Next one is logical two-tier client-server architecture. So look at this diagram here. This is client tier and database tier. This is a two tier. So client server technology or architecture. So these are client one layer or one tier, and this database on another layer. Now you can see the diagram, another diagram here we can easily make out. So this is the network, and here all clients are on one side and all servers are on another side. So here these are the servers where the database sits, or these are the servers where the clients make use of these database. So here in two-tier architecture, there are two different layers, one for client layer and another for database tier. Now look at definition of this. In this architecture, client is placed on the different tier and database is placed on different tier. The same thing. This is on different tier and this is on another tier, and there are two tiers. And two tier, it is also known as client server architecture, is used for user interface program and application programs that runs on the client side. Here these two are on different tiers. Clients are on one tier and database is on another tier. And how do they communicate? I mean, the clients communicate with the database through an interface, nothing but application programs. So here, through application program, there is an interface through that these clients will communicate with the database, or they will work with the database. Now look at one more point. An interface is called an ODBC. This is called Open Database Connectivity. So this is an interface. With the help of this, it allows client-side program to communicate with DBMS, Database Management System. So this is two-tier architecture where clients are on one side or on one tier and database on another tier or another side. So they communicate, or the clients communicate with the database through an interface that is called ODBCs or connectivity. So this is two-tier architecture. Next one is logical three-tier architecture or client-server architecture. See, here in this architecture, commonly used architecture for web applications. One of the application of three-tier is a web application, and intermediate layer called application layer or web server that acts like a medium for sending data between the database server and the client. In three-tier architecture, we can observe this. There are three different tiers or three different layers. Here one is, the example is web application. This is the application of three-tier architecture. And here, if you observe this, it is a medium for communication and sending data between the database and the client. Here again, we can make out one layer, the clients will be on one tier, and database is on another tier, and in between we have application program or application program stored in a server. Now look at this diagram here. In this layer, there are three layers. So this is known as, one is database layer, and this is a database tier. This is database tier, and second one is application tier. Next one is presentation tier. So in this example, if you observe this, there are three different, and here this is a medium. This is another intermediate layer or intermediate tier, which helps to communicate between the database as well as the user. And actually, if you talk about client, then presentation layer, we find this clients. Clients generally will be in presentation layer or tier, and in between we have application program or web page and application server or web server, and here we have database server. So we can make out here three different tiers. Now let's see the definition of this. One is database tier. This is database tier. Here only database is present. It also contains all the relations and constraint. Relations is nothing but another name of table is called relations, and relational database, and also it has so many constraints. So this is the way there is called database tier, where you find only the database. Second one is application or tier or middle tier. It is a middle tier. So at this tier, the application server and program which access database resides. So this is one more tier here where we are storing the application programs, or this is nothing but an interface or a medium for communication between the client and as well as the database. Next one is user or presentation layer. This is the interface here. This is an example for that. So an end user sits on this layer. At this layer, multiple use of databases can be provided by the application. So here the user at this layer, presentation layer, user will be in this tier and he will work with the database through the programs or through application server or the programs in the application server. And with this application program, it provides the user with different types of views of a database. So this is a 3-tier client server architecture. Now let us move on to next slide. Next concept is database models. So database models. So database model or simply data model is an abstract model that describes how the data is represented and used. Actually, what's a database model? And it is almost connected with the database architecture or with the database design. So where it shows it is an abstract model. It is not complete. It is an abstract view. It is an abstract model. It describes how the data is represented and used in a database. How the data has to be stored in a database, and how do the user can access this database. So this is nothing but database models. So generally we have the 3 different models in use. The one is hierarchical model, network model, and relational model. These 3 are different models available or in use with respect to database or database management system. Now let us move on to next slide. So first one is hierarchical model. The hierarchical data model is the oldest type model developed by IBM. And this data model organizes the data in a tree-like structure. And whenever we talk about tree-like structure, and here this is called child node and as well as parent node. This is the common terminologies. So child node as well as parent node. So this comes in hierarchical data model. So here data is arranged in the form of a tree. Now the database based on hierarchical data model comprises of a set of records connected to one another through links. Here, as we have seen just now, the child node and the parent node. So here child node and the parent node are connected to each other through links. And the top of the tree structure consists of a single node is called the root node. So what is a root node? The first node, the first record of a database in this model, that is called a root node. And there are 2 types of relations, one-to-many and one-to-one. There are 2 types of models, that is one-to-one and one-to-many. So this is nothing but hierarchical model. Now let us see the schematic diagram. How do we represent this in database? So for example, this is hierarchical model. This is, for example, the department and department number and department name. And in the department, we have course. This is course number, course name and unit. And student, this is student number, student name and course. And here ID, name, this is professor, this is one more unit. So here, look at this diagram here, root. This is the root. Under that, we have parents, 1, 2, 3. There are 3 parent nodes. And this is called the root node. This is the top node in this model. And here, this parent has 2 childs in this example. And this parent had 2 childs here. So this is an example of hierarchical model where the data or the records are stored in a hierarchical model or in the form of the parent and child. So this is hierarchical model. Now let us move on to next slide. Next one is network model. So what is a network model? In a network model, the data is represented by a collection of records and relationships among the data represented by a link. Here, what is the relation? Another name of a table is called relation, and we are going to connect different records or different tables through logical links. So this is in network model. Here, data represented by a collection of records, and the relationship between among different records is also possible through these links. And the link in a network data model represent an association between two records. So the connectivity or the common factor between these two records. And the next main difference between hierarchical model is that data is organized in the form of trees, and in network model the data is organized in the form of graph. That is the main difference between these two. That, and here in hierarchical model, what you have seen in the previous slide, here we have a root, then parent, then child. All these are connected through links, but here in network model, all these are connected through a logical link between the records, and it is in the form of graph. So this is a network model. Now we can see the diagram for this. See, this is a network model. Department number, department name, student number, name, course and student, and the course, one more record here, number, name, unit, and here professors. So here you observe this name. If you observe this name is connected to this here student number or student name. So department number, department name, and the student number, and again the course what he has taken. If you observe this here, all these are connected or interlinked through a links. So this is an example for network model. This is one more model, that is network model. Now let us move on to next slide. Next one says relational model. Another type of database model is relation model. So in this model, it was developed by E.F. Codd in 1970, and all the data maintained in the form of tables. It is known as relations, and it consists of number of rows and number of columns. And in this example, as you know, what is a relation table? Table is nothing but it is made up of number of rows and columns, and all the data are stored in a database or in a table in rows and columns. So it consists of rows and columns. The relationship between the two tables is implemented through common attribute in the table and not by physical links or pointers. So in relational model, so as we have seen in the previous two models, and here we are going to make use of links or connectivity. We are connecting two different records through a logical links, but here we are connecting not by physical links, by making use of an attribute, the common attribute. Attribute is nothing but a column. So we are going to connect two different tables through a common column or nothing but an attribute. And the relational model has become more programmers friendly. This is an advantage of this, and dominant and popular in both industrial and academic scenarios. Generally, we are using this in the field of academics as well as industrial applications. And example here, Oracle, Sybase, and Ingres Informatics, these are all different popular or DBMS software or relational database management system software. These are example for this relational model. Now let us see the difference between the hierarchical as well as this relational model. In the relational model, look at this diagram here, department number and name, and here professor, department number and course, and this is student. This is nothing but there are four different tables, nothing but four different relations, and we are connecting through a common attribute. So here student, course as well as course. This is a course table, course number. If you observe this, say department number and a professor, his comes on department number. So here department number, these two are a common attribute, and we are connecting these two tables with department number here. And here if you look at this student course, in this comes under course table. In this relation, the course number is going to match with this course of a student. So this is how the link between the different tables through a common attribute. So this is relational model. In this session, we have discussed about the database architecture and different database models. We will continue our discussion in my next session. Thank you very much.